How's it going? This is a little bit of periodic trends. And all of, so periodic trends would be like atomic radius, size of electron, which is the size of electron cloud, ionic radius, ionization energy, the energy it takes to pull an electron away, electronegativity is the ability to gain electrons. They're all based on this Coulombic attraction thing. So get used to using this a lot, this word Coulombic attraction. Almost all your explanations need to involve Coulombic attraction. It's not too complicated. All it's based on is the fact that positives and negatives attract. There's an attraction between a positive and a negative. Okay? And the more positives you have, the stronger that attraction is. There's a lot stronger pull for that electron if there's more of these. So think of the positive protons in the nucleus of an atom as like magnets for electrons. The more protons there are, the more positives, the more Coulombic attraction, the more attraction for that electron. Okay. Now, if you think about magnets, now there's something else that affects magnetic strength. Okay, besides the strength of the magnet itself, but how far apart a magnet is from the object is trying to attract. If things are a long ways apart, it's very hard for them to attract. If they're close together, magnets pull together. So if we had this positive proton and this negative electron versus this positive proton and this negative electron, there's going to be a lot more attraction between these two than there is these two. So think of the protons in the nucleus as like magnets for electrons out there. They have some attraction for those. Okay, and more protons, more attraction. Closer distance, more attraction. So there is a little formula for Coulombic attraction, and the force of attraction, that's the force of attraction, is equal to Q is charge. So it's equal to how much positive charge we have and negative charge we have divided by the distance squared. So not that you need to use this equation, but the more charge we have, these numbers get bigger, the more the force of attraction is between the positives and negatives. And the smaller the distance is, this gets smaller, the more the force of attraction is. So notice distance is squared. Distance has a big impact on that force of attraction. It's weird that the force of gravity, if you take physics, is equal to, so there's always gravity between two objects. If you take the mass of one object times the mass of the other, divided by distance squared, that's what the force of gravity is. So if you think about the mass of the Earth times the mass of the Sun divided by the distance between them, that's the gravity between the Earth and the Sun. So similar type equation. All right. So our trends, let me talk about a couple things here. So one of the things would be this. I'm going to go to your notes, maybe. All right. So periodic trends. So atomic radius is one of these. Okay, one of these. A couple of terms in here. Effective nuclear charge, or Z effect, is the net charge felt by the outermost electron in an atom. Okay, so what that means is, if we have a nucleus and we have some electrons, I don't have equal positives and negatives, but that's okay. So these protons have some attraction for those electrons. Well, there's more attraction for these electrons than there is this electron. So the farther out electrons are, the less attraction there is for that nucleus. Okay, the farther out it is, the less attraction is for that nucleus. Now, if I add another electron out here, this electron is going to feel the same attraction as this electron is. Okay, those are going to feel the same attraction out there. The ones in the outer energy level are going to feel the same attraction. There is something called shielding effect, okay, which we'll talk about a little bit in class, but the inner level electrons shield the outer electrons from feeling the pull of the nucleus. So if there's a whole bunch of inner electrons, they kind of shield those outer ones from feeling the pull of the nucleus. Okay, That will not be a huge deal, but that'll happen a little bit. All right, let's talk about atomic radius. Atomic radius here. So here's our periodic table. First thing, as you go down a family, you're adding energy levels. Electrons are getting farther from the nucleus. So if we compare like beryllium, which would have 4 protons in the nucleus with 2 energy levels of electrons, it's going to have a fairly small electron cloud. So atomic radius is basically the size of the electron cloud. It's actually 1/2 the distance between nuclei of adjacent atoms, but it's essentially the size of the electron cloud is atomic radius. Well, beryllium's only got 2 rings. Compare that to strontium, which has 38 protons in the nucleus. It's going to have 1, 2, 3, 4, 5 energy levels of electrons. Strontium is a substantially larger element. Even though it's got more protons, those protons can't pull on those electrons out here, as well as these protons can pull on those electrons, because there's such a distance between them. So as we go down a family, electron cloud gets larger, atomic radius gets larger because the electrons are getting farther from the nucleus. Making a video. Do you want to get in it? There's Anna. You guys can say hi to Anna. All right, sorry for the pause there. Again, so atomic radius getting larger as you go down. You're gaining energy levels, so the less Coulombic attraction for the protons to the outer level electrons because they're farther from the nucleus. As we go across a period, so from from potassium over to krypton. You would think that the elements would get larger. You're adding protons, you're adding neutrons, you're adding electrons. But the radius actually gets smaller as you go across a period. So here's why. All of these elements have 4 energy levels of electrons. They all have 4 energy levels of electrons. So their valence electrons are starting off about the same distance from the nucleus. Krypton has 36 protons, so 36 magnets for those valence electrons. Potassium only has 19. So there's more Coulombic attraction between the protons in krypton than there are with the electrons than there are between potassium. So every time as we move across this way, in general, there's going to be a couple of changes in this, but in general, as we move across this way, elements get smaller electron cloud because we're gaining nuclear charge. Okay, increase in nuclear charge, meaning increase in number of protons. Increase in nuclear charge, which causes an increase in the valence electrons because the valence electrons are all in the same outer energy level. So if we compared like sodium with magnesium, so sodium's got 11 protons, 2 energy levels of electrons. Magnesium's got 12 protons, 2 energy levels of electrons. Magnesium's a little bit smaller. Okay, the valence electrons are both in the second energy level. There's only 11 protons here, and there's 12 here having a stronger pull for those valence electrons in magnesium. So your explanation has to be valence electrons are the same principal energy level, valence electrons are the same energy level. More protons, so more Coulombic attraction. Okay, or you can say more nuclear charge, so more Coulombic attraction for those valence electrons, which makes electron clouds smaller. All right, there's atomic radius. I'm going to stop at that for now.